We humans, we've always been explorers, we've sailed the seas, conquered mountains, and even walked on the moon, but our thirst for knowledge, for the unknown, it doesn't stop there. We look up at the night sky, at the twinkling stars, and we can't help but wonder, what's out there? What lies beyond our own cosmic backyard? Well, my friends, that's where things get really interesting. See, the space between the stars, what we call interstellar space, isn't just an empty void. It's teeming with mind-boggling phenomena, things that challenge our understanding of physics and make science fiction look tame. In this video, we're going to take a trip through interstellar space, exploring some of the most mind-blowing facts that will leave you in awe of the cosmos. So, you're ready to journey into interstellar space, huh? You might think we need to travel light years to get there, right? Well, here's the first mind-blowing fact. Interstellar space is closer than you think. It's not some distant realm reserved for science fiction. Nope, it begins right outside our solar system, just past a boundary called the heliopause. Think of the heliopause as a cosmic bubble, blown up by our sun. Inside this bubble, we're protected from the harsh radiation of interstellar space by the solar wind, a constant stream of charged particles flowing from the sun, but eventually that solar wind weakens and its influence fades away. That's where the heliopause comes in. It's the point where the sun's influence ends and true interstellar space begins. Voyager 1, like a true cosmic pioneer, actually crossed the heliopause back in 2012, becoming the first human-made object to enter interstellar space. And its twin, Voyager 2, followed suit in 2018. These spacecraft, even after all these years, are still beaming back data, giving us an unprecedented glimpse into this uncharted territory. Interstellar space isn't just an empty vacuum, it's filled with powerful cosmic radiation and unexpected magnetic fields that scientists are still trying to wrap their heads around. Okay, so we've established that interstellar space isn't some empty void, but what exactly is out there, lurking between the stars? Well, it's something called the interstellar medium, or ISM for short. Now don't let the name fool you, this isn't some boring intergalactic waiting room. The ISM is a fascinating mix of cosmic ingredients, a recipe for star formation and galactic evolution. What's in this cosmic soup, you ask? Well, we're talking about clouds of gas, mostly hydrogen and helium, the most abundant elements in the universe. But there's more. We've got dust grains, tiny particles formed from the remnants of dead stars, scattered throughout the vastness of space. And let's not forget about plasma, a superheated state of matter where electrons break free from their atoms. In some regions, these ingredients clump together, forming massive, awe-inspiring nebulae. These nebulae are like stellar nurseries, where the raw materials of the universe coalesce under gravity's pull to ignite and give birth to new stars. The ISM isn't uniform, it's more like a cosmic patchwork quilt, with some areas dense and clumpy while others are eerily sparse. Even though the ISM has a very low density, it plays a crucial role in the grand scheme of things. We've all gazed up at the night sky and pondered the vastness of the cosmos. But what if I told you there are billions of planets out there that aren't tethered to any star? They're cosmic nomads wandering the interstellar void alone. We call them rogue planets, and they challenge everything we thought we knew about planetary systems. These planets were ejected from their stellar homes, flung out into the darkness of interstellar space. Some scientists believe rogue planets could harbor internal heat and even liquid water. For a long time, we humans looked up at the vastness of space and wondered if we were truly alone. In recent years, we've received convincing evidence that we're not as isolated as we once thought. We've had visitors from other star systems like Oumuamua, the first confirmed interstellar object. This mysterious object, shaped like a giant cigar, came whizzing through our solar system in 2017. Astronomers were baffled by its strange shape and unusual trajectory. In 2019, another interstellar visitor, Comet 2I/Borisov, was discovered. Unlike Oumuamua, Borisov looked more like a typical comet with a visible tail. Alright, space enthusiasts, let's get real for a moment. As awe-inspiring and mysterious as interstellar space may be, it's also an incredibly harsh and unforgiving environment. One of the biggest threats to future interstellar explorers? Cosmic radiation. You see, here on Earth, we're pretty lucky. Our planet's magnetic field and atmosphere act like a giant shield, protecting us from the constant bombardment of high-energy particles that permeate space. But out there, in the vast expanse between stars, there's no such protection. Cosmic rays, those subatomic particles zipping through space at nearly the speed of light, are a constant danger in interstellar space. They originate from powerful events like supernova explosions, active galactic nuclei, and even the supermassive black holes that lurk at the centers of galaxies. These cosmic rays can damage sensitive electronics, disrupt communication systems, and even alter the very structure of DNA, increasing the risk of cancer and other health problems for astronauts. Scientists are hard at work developing advanced shielding technologies, but for now, cosmic radiation remains one of the biggest obstacles to interstellar travel. So, while we dream of sending humans to the stars, we need to find a way to protect them from this invisible threat. Okay, get ready for this one, because we're about to dive into the mind-bending world of Einstein's theory of relativity. When it comes to interstellar travel, we're not just dealing with vast distances, but also with a phenomenon that sounds like something straight out of science fiction: time dilation. You see, according to Einstein, time isn't absolute. It's relative, meaning it can be affected by things like gravity and velocity. And when we're talking about interstellar travel, where spacecraft would need to approach a significant fraction of the speed of light, time dilation becomes a very real factor. Here's the gist. The faster you travel through space, the slower time passes for you relative to someone who's stationary. It's like something out of a time travel movie, but it's a real phenomenon predicted by physics. Now, at everyday speeds, this effect is negligible. But as you approach the speed of light, time dilation becomes increasingly pronounced. Imagine astronauts embarking on an interstellar journey, traveling at, say, 90% the speed of light. For them, time would pass much slower than it does for us here on Earth. They could travel for what they perceive as a few years, but when they return to Earth, decades or even centuries could have passed for the rest of us. We've explored the wonders and dangers of interstellar space, but perhaps the most profound question remains: are we alone in the universe? Now, when we think of extraterrestrial life, we often picture planets orbiting distant stars, maybe with lush forests, sparkling oceans, or even bizarre alien landscapes. But what if life, in some form, exists not just on planets but within the vast expanse of interstellar space itself? It's a bold idea, but some scientists believe it's possible. They theorize that microscopic life forms, what we call extremophiles, could survive the harsh conditions of interstellar space, hitching rides on rogue planets, comets, or even those intriguing interstellar objects like Oumuamua. This theory, known as panspermia, suggests that life could be distributed throughout the galaxy, carried from one star system to another by these cosmic vessels. Imagine that life on Earth, instead of originating here, could have been seeded from another star system, brought here billions of years ago by a comet or asteroid that originated in the depths of interstellar space. We've journeyed through the wonders and perils of interstellar space, uncovering its secrets and grappling with its mind-bending physics. But one question still beckons: will we humans ever walk among the stars? It's a question that has captivated dreamers, scientists, and science fiction writers for generations. And while interstellar travel remains a daunting challenge, it's no longer a fantasy confined to the realm of fiction. Scientists and engineers are hard at work, developing technologies that could one day make this dream a reality. One such project is the Breakthrough Starshot Initiative, a truly ambitious endeavor that aims to send a fleet of tiny light-powered spacecraft to our nearest stellar neighbor, Proxima Centauri. These spacecraft, called starships, would be propelled by powerful lasers here on Earth, accelerating them to a significant fraction of the speed of light, allowing them to reach Proxima Centauri within a few decades. Imagine that, receiving data and images from another star system within our lifetime. It would be a monumental achievement, forever changing our perspective on our place in the cosmos. From rogue planets roaming the galaxy to the mind-bending effects of time dilation, interstellar space is a cosmic tapestry, woven with wonder, danger, and endless possibilities. It's a realm that challenges everything we thought we knew about the universe and ignites our imagination with dreams of reaching for the stars. The journey ahead won't be easy. Interstellar travel presents immense technological hurdles, from shielding against deadly radiation to finding ways to travel at speeds that would make even Captain Kirk envious. But the human spirit of exploration, that insatiable curiosity to push beyond the boundaries of the known, is a powerful force. As technology advances and our understanding of the cosmos deepens, who knows what incredible discoveries await us in the vast expanse between the stars. The universe is full of surprises, and that's what makes exploring it so exhilarating.